Welcome to Accelerated Engineering. My name is John, and this is the video encyclopedia entry for the hyperbolic sine function, or SINH. The hyperbolic sine function takes an input argument in radians, or an input angle in radians, and calculates the hyperbolic sine. Hyperbolic sine is analogous to the ordinary sine, but instead of being defined by a relationship to a circle, it's defined in a relationship to a hyperbola. Hyperbola. So in this case, the SINH function is related to like this arc length here along the hyperbola, and then the angle that's described is actually only like half of your input argument. Kind of a messy one. Hyperbolic trig functions are a little bit crazy. But it keeps this function at least reasonably well defined across large angles because it's always cut in half and then mapped onto this hyperbola. To show this function, I've generated a large number of values in degrees, and then in column B converted them to radians and taken the hyperbolic sine of that. And we can see that this extends to a very large value as x increases in the positive direction, and a very large negative value as x increases in the negative direction. For very small values approaching 0, this function behaves very, very well. For 1 times 10 to the negative 307 in my little logarithmic calculator, the value approaches the input value, similar or analogous to the sine function. As we go to increasing values, though, we can see that even for the value 10, 1 times 10 to the 1, the output value is already 11,000. So this works best for input arguments that are much closer to, well, are much closer to 0 for small numbers. We're thinking about the value, let's see here. 120 degrees is, 120 degrees is 2 pi over 3 radians, and that's kind of where we're already starting to explode. That value looks to be about 4. You just scroll down here, do the same for negative, just in the opposite direction. Yeah, it's almost exactly 4. That was serendipitous. Anyway, the largest value that the SINH function, the hyperbolic sine function, can take in is actually bounded by the largest value that it can put out. So for example, if I input 10 times 2, or 10 raised to the power of 2.5, which is about 300, my output value is already 1 times 10 to the 137, which is a ginormous number. That's a technical term, ginormous. If I multiply by 2.8, this is only about 600, and we're already approaching the max value that Excel can represent, which is 1.7-ish times 10 to the 308. At 10 raised to the power of 2.9, the output value is just too large. It cannot be expressed. So there we go. That's kind of the input limits. We already saw that it was well behaved for very, very small numbers. Some related functions to the hyperbolic sine are the hyperbolic cosine, hyperbolic tangent. The inverse would be the hyperbolic cosecant of x. And then there's always the analogous bounded by circle sine function. This concludes the video encyclopedia entry for the hyperbolic sine function. If you haven't already done so, please like this video and subscribe to the channel if you want to see more content like this. Thank you for watching.